Welcome back. I am Anshu and you are watching Bottleneck. This is the Agenti AI Cookbook series where we learn and implement design patterns for AI applications using hands-on examples. In our previous video, we explored adaptive dynamic routing in Agentic AI. I hope that gave you a clear understanding of how intelligent systems can adapt and choose the best path in the real time. In case if you missed on my previous video, I will be sharing the link in the description. In this example, we explore routing pattern in Agentic AI using a practical and relatable use case, a customer support agent. Customer support is one of the most common and impactful applications of autonomous agents. These systems can handle routine queries, assist with orders, resolve technical issues, and even escalate complex problems, enabling 24 by 7 support while improving customer satisfaction and reducing the operational cost. Now, the key challenge in such systems is correctly understanding the user's query and directing it to the right expert agent. That's where the routing pattern comes into play. Routing allows the AI agent to analyze incoming requests and dynamically choose the most appropriate path to handle them. In this implementation, we classify user query into three categories: billing, technical, and general support. Each category is handled by a specialized agent. For example, billing related queries are handled by a billing agent, technical issues are routed to technical support agent, and general or FAQ type questions are answered by general support agent. To make this more robust, the example demonstrate multiple routing strategies like we had discussed in our previous video. The first one is ML based routing. It uses TF-IDF vectorization combined with logistic regression trained on sample data to intelligently classify queries. Second is LLM based routing. It leverages a large language model with a carefully crafted prompt to determine the appropriate category. Third is embedding based routing. It computes cosine similarity between the query's embedding and pre-computed route embeddings to find the closest match. And finally, rule based routing, a straightforward keyword match that is fast, transparent, and easy to configure. If you look at the workflow, it starts with a user query which is passed to a router. The router determines the appropriate category and then uses conditional branching to forward the request to the correct agent. The selected agent processes the query and generates a response which is then returns to the user. In the hands-on example that follows, we will talk through how this routing logic is implemented using land graph and how different strategies can be plugged in or swapped depending on the use case. Alright, let's take a look at the dependencies that we are going to use in our use case. The first is the LLM itself. I am using Grok. You can use any other based on your requirement and your access. Second is the TF, IDF and logistic regression. I will be using from scikit-learn. Then we will be using LangChain core and LangChain graph. Finally, the NumPy for cosine similarities. All right, so let's start the implementation. All right, let's add the imports now. So first would be import LLM utils as my LLM to initialize the LLM. Second, we need the vectorizer and the logistic regression. So from sklearn dot feature extraction dot text import tf idf vectorizer, and from sklearn dot linear model import logistic regression. All right, few things to note here. For our use case, we are using a simple linear classifier as logistic regression, but in real-time scenario, this will be driven by the domain and the business use case. The data or the sample data that we are going to use here will be coming down from a specific source like log or maybe some database. which will be used to train the logistic regression. All right, so let's start with the ML based router. Okay, so ML based router will require a sample data like any other machine learning algorithm. Okay, so let's create the sample data. Sample data will be an array of texts. Okay, what would be the first use case? Let's say refund and not received. Okay, now what could be the second entry? Well, payment failed. Sounds good. Both are eligible for billing type. All right, now let's add some technical entries. App is crashing. Okay, now let's make another entry. Say bug in the system. All right, now let's add some FAQ type entries. Okay, so what is your service request? What is your, all right, let's make it all small cap. What is your service request? Okay, and finally, how does it work? Okay, we have 6 entries, so we need 6 labels. First is billing. Second one also looks like billing. Okay, third one, it looks like a technical agent. Okay, so it's type technical. Okay, fourth is also a kind of technical query. And the last two sounds general query. All right, so we have 6 type of activities or queries and their labels ready. Now let's first vectorize the information. So let's create the vectorizer or initialize the TF-ID of vectorizer, and let's vectorize the entire data. So vectorizer dot fit transform, and let's give the entire text. Okay, now data is vectorized. Now we need to initialize the model. So model would be the logistic regression in our case. All right, initialize it. Now we fit the model dot fit with the vectors that we created, and we with the labels that we have. All right, so now the model is ready for prediction. Let's create the ML based router. Okay, so we are creating a node basically, or ML based router. It is not a node yet. Okay, state. We know how this shared schema works from our previous video. Let's add the comment here. So this is ML based router to classify the user query. Okay, using logistic regression. All right, now let's add some value to it, how it is going to classify. So first thing is we need to convert our input query into a vector. So what is the query that we have? So it is going to be a query from the shared state, that is a query again. Okay, so we get the query from the state, then we vectorize it. So what we do is vectorizer dot transform, and we feed in the query. All right, so we have the query vectorized. Now we need the prediction, so response. All right, so response, we have the model and we just need to predict. All right, and provide the value x. Now what will happen here? When we do a prediction, it will provide a list of values. So we have three different kinds of label: billing, technical, and general. So when we receive an output, it will be with different weights that are the probabilities. Basically, the higher probability will be the first one, followed by the next, and so on. Now we need the data with the higher probability, so we add, or we take the head of this array, all right, from the response. Now if you want to get the probabilities as well, you can use model dot predict prob, okay, here with the value x as the vector that we have created. So this will give you the probabilities that are being generated and which one is the max probability value that we have. Once we have this response picked up, okay, now we will return a partial dictionary, same as we did before in our previous use cases. All right, so let's add in here. So it will be a route, and the value that we are going to get is prediction, okay, sorry, the response. All right, so this is ML based. Now let's do a LLM based, okay. So next is LLM based router. LLM based router. All right, so as we know from our previous experience, for LLM it requires a prompt. Let's import the prompt first. So we will be getting the prompt from langchain core dot prompts, okay, import chat prompt template. It will help us to create the prompt, and we need a parser, langchain dot output parsers, import string output parser. All right, these two things we need for our prompt. So let's go down. All right, now call upon the let's create the LLM or the router prompt. Okay, now this router prompt, okay, from template. Okay, so now let's create this prompt, okay, as a multi-line. Let's add the values here. So what we need to do is analyze the user query and output only one category. Okay, so what would be the categories? First is the billing, second is technical, and third is general. All right, so we have these three categories. And what would be the query? Query is the query shared by user. All right, now we need the LLM. Okay, so LLM would be my LLM dot initialize grok LLM. You can have your own LLM. As of now I have grok. All right, let's create the chain. So LLM router chain, okay, which will have the prompt. So let's fix the spelling here. Router prompt. All right, so it's going to be router prompt pipe LLM pipe string output parser. Okay, so this will give us a streamlined AI output. All right, now let's create a method or a node for LLM router. Okay, now this will also take a state as a shared schema, which will be used by state graph. And what it is going to do, it is again LLM based classifier for user query. Okay, query. Okay, now Like any other LLM, it will be invoked. We need to invoke the chain and it is going to return a partial dictionary. So what it is going to return? It will return a route like before, and it will be, we need to invoke the LLM chain. All right, invoke. This invoke will take a dictionary. As we know, this is a runnable with the dictionary as an input, which will take query, and finally we will pass the state query. Okay, so we had discussed in detail how this will work. All right, so now we have the LLM router ready. All right, this video has run a bit longer than expected, so we will pause here. In the next part, we will continue with our implementation with the rule-based and the embedding-based routers. We will build the complete workflow by defining nodes, constructing the graph, and connecting everything together into a fully functional agent. So stay tuned. Now, if you find this helpful, don't forget to like, share, and subscribe for more practical insights into AI architecture and design. So, see you in the next video. Thank you.